Hi, welcome back. I'm Tammy and I do math for coffee, and today we are going to do solving systems by substitution. The idea of substitution is that you're going to replace a variable with whatever it says that variable is. So in this problem number 1, we got y equals -1, but then it also says that y equals 2x minus 17. Well, if y equals both of those things, then it makes sense that we could just set up an equation saying that they equal each other. Let's just solve this equation. Pretty straightforward. So as we go through and solve that equation, kaboom, there we are. We have x equals 8. Now, here's the tricky part though. When you're solving a system, they want to know what the x is and they want to know what y is. You might feel done right here because until now we've just always solved for x, but we also have to figure out what y is. This one's actually pretty easy because it straight out tells us that y is -1. And this is how you write your solutions for a system. You write them as an ordered pair, 8 and -1. There is another way of solving a system like this, and that would be to graph it. And if you haven't seen that video yet, I'll put a link up here in the corner and you can go check that out. Visually, the idea here is that these are two lines that when you graph them will intersect, and that's why we write these as solutions as ordered pairs. Oh heck, why don't I just do that for you right now? Take a look at this picture. All right, number 2. The system looks a little more complicated, but you have one of these that is solved for y. It says y equals 8x minus 11. I'm going to just stick that in here to the first one for y, and I'm just going to replace it or substitute it. So I copy this first equation, 4x plus 6 times y equals -14, but instead of writing a y, I just left a big blank here because I'm going to pop that 8x minus 11 right in here. You're making an equation sandwich. The y goes in the middle. And then from here we do the algebra that we're looking at. It's going to be distributive property that comes up next, right here. We're going to take 6 times 8x, and we're going to take that 6 times the -11. Next line, we recopy the 4x. Multiplying through, that becomes 48x minus 66 equals -14. That's all I did is I multiplied the 6 through here. Now the next thing I need to do is combine like terms and keep solving, apparently. And that's what I did. Just pause it right here and take a look. So I combined like terms and we get 52x minus 66 equals -14. Add 66 to both sides. 52x equals 52, so x must equal 1. I bet you're fast with your algebra, but not that fast, right? We know what the x is, but we have to find the y. Well, they gave us an equation for y, which is pretty slick. Now I'm writing very slowly. Yay, computer. There it is. Now, since I know what the number is for x, I'm just going to pop that in here, and it'll be 8 times x minus 11. I know that that number is 1. Multiplying through and solving, we end up with y equals -3. Write your solution as an ordered pair. The thing I'm concerned about when you're first learning systems is that up to this point, solving equations, super habitual to just stop at x. You're going to get in trouble. You're going to lose some points when you do these for your teacher if you do not continue through and get the y as well. All right, number 3. In this case, neither one of these is solved for a variable. So I spy with my little eye that this x is just one x, and I think that would be the easiest thing to do. So the first thing I have to do is solve for this x. I just manipulate one of the equations until it looks the way you want it to look, like where it says x equals something or y equals something. So let's copy it. Add 6y to both sides, and we get x equals 6y minus 18. This x is now going to get substituted here for this x. So I leave a big spot there. And all I did was recopy the first equation where it said 2 times x plus 6y equals 18. 2 times something plus 6y equals 18. We know what the something is. It's this 6y minus 18, so we'll drop that in right there. Now we're going to simplify all this and solve for y, because that's the variable that we have here. This will be distributive property again. 2 times 6 is 12, so that's going to be a -12y because the 2 is negative. Negative times a negative is a positive. 2 times 18 is 36. The 6y was already there, and the 18 was already there. Now we need to combine like terms. I have a 12y and a 6y that I can put together. And I kept going really fast, but here it is. 12y plus 6y is negative 6y plus 36 equals 18. I'm going to add 36. No, I'm not. I'm going to subtract 36 from both sides here. Just for space, I did a lot of this stuff in my head. If you're doing this on your own, you might want to write this out. So if you write minus 36 under both of these, 18 minus 36 is negative 18. This isn't the same number with the sign changed. I actually subtracted 36 from this positive 18 right here. Now you divide both sides by negative 6 and you get y equals 3. Now we have to find the x, and I'm going to go in here and use the formula that has the x in it. It said x minus 6y equals negative 18. I know the y is 3, so it's x minus 6 times 3 equals negative 18. Y minus 18, because negative 6 times 3 is negative 18, equals negative 18. Well, the only way that's going to work is if x is 0. So our solution is 0 and 3. Number 4, 7x plus 5y equals negative 21, x minus y equals negative 3. Same thing again. We do not have an equation that's already been manipulated for us to say x equals or y equals. I'm going to go for the x again because it's positive. It'll be pretty easy just to add y on both sides. So I'm copying it down first and then adding y on both sides, and I get x equals y minus 3. This is going to be what I substitute in over here. I'm going to rewrite that with a big blank. Now let's pop the y minus 3 in there. We're going to do the distributive property. Combine like terms. So 7y and 5y is 12y minus 21, doesn't change, equals the negative 21, which is over here. Add 21 to both sides, I get 12y equals 0, so y must equal 0. Now substituting this back in, you can put it into either one. That might be a question you're having right now, is how do I know which one to substitute back into to solve the x? But since you can put it into either one, I usually use the one that's the easiest. It doesn't have a lot of coefficients, so there won't be a lot of division. So I just did x minus y equals negative 3, x minus 0 equals negative 3. So I get y equals negative 3. Write your solution out as an ordered pair. Now we got to talk about what happens when some weird stuff starts happening. Number 5. I'm going to go ahead and just do this problem, and you won't see what's happening until you get halfway through or all the way through, and then something weird happens. And it's not that you did anything wrong. That's why I want to go over it. So let's solve for x and then substitute it into the second equation. Here's one thing. Don't substitute back into the one you just played with. Take the first equation and substitute it into the second equation. So we put the 7y plus 7 in there, we run the 2 through with distributive property, and we start simplifying, and you're going to notice weirdness start happening now. Here's the 14y and the negative 14y. Well, when you put those two together, they just cancel each other out. That's 0. So we write down whatever you have left. You have 14 on one side of the equation and 4 on the other. This is false. This is an untrue statement. But at this point, if it were me, I'd be going back and checking my work to make sure I didn't do anything wrong. But if you absolutely did everything correctly, right here, there's nothing wrong. There's no mistakes. There's no multiplication or adding error. This is what I'm getting. When you run into a system that does this, the answer is no solution. Now, a quick look at the graph of these is going to explain why. They're parallel lines. Those parallel lines are never going to cross. I just want you to have this visual that whenever you see no solution, it doesn't mean anything went bad. It just means you are looking at parallel lines and you just can't see them because you didn't solve by graphing. That's okay. Okay, now it gets really weirder with number 6. That's the one I'm going to solve for. So I have something to substitute into the second equation. And I chose that one because it's just 1x already. I don't have to do any division. It's going to come out really nicely. So all I did was subtract 8y from both sides, and I get x equals negative 8y plus 3. We're going to squish that into the second one. Got to make some room, and there it goes. It's all squished in. Now we do distributive property, get what we get. And look at that. The 16s are going to cancel out again. So you might be thinking there's no solution, but let's write down what's left. 6 equals 6. Well, that's the opposite of the last thing. That is always a true statement. You're going to run into these problems, and whatever the number is doesn't really matter. It could be 10 equals 10, -4 equals -4. If you get something that is always true, your solution is all real numbers. That's one thing you can write down, or you might write down infinite solutions. Well, let's take a look at the graph of this. When I graph these two lines, it's like you can't see two lines because they're actually the same line. When I graph one, the second one maps right on top of it. They are the same line. Let's go back and look at the system. Check out these numbers. X times 2 is 2x, 8y times 2 is 16y, and 3 times 2 is 6. This is actually the same equation. It's just the second one has everything multiplied times 2. Usually when you're in this unit, your teachers are going to want you to do it 3 different ways. And the first way was solving by graphing. Go back and look at that video if you need to refresh yourself on how to do that. The next one is going to be solving by elimination. It's right here. Click into that one next. Thanks for watching. I'll see you next time.